today we're going to be discussing absolute value inequalities. This is the second part to our absolute value equations. In inequality, we have to remember to flip the sign when you are multiplying or dividing by a negative. This is something we already know. What we also need to remember is that inequality symbols are going to be symbols such as less than or equal to, greater than or equal to, and greater than. Okay? You're going to pretend that the inequality symbol is an equal sign, and you still must have case 1 and case 2. So here are the steps. Steps in solving absolute value inequalities. Step 1, you still have to isolate the absolute value. Step 2, you're still going to check to see if it's possible. Step 3, you're still going to do case 1 and case 2. You're still going to solve them. But now we're adding number lines, and then we're going to do the final answer. Okay? Now, the biggest thing that your brain needs to grasp is that we have compound inequalities, and compound inequalities are going to be the and and the ors. Now, when we have an and statement, your graphs are going to overlap, meaning x is tracked. If I have an greater than, that is going to be an or statement, and that is whenever it goes in the opposite direction. So less than is and, greater than is or. Less than is and, greater than is or. Okay? So we're going to go right ahead and we're going to start this. Now, the very first thing I want your brain to look at is say, okay, well, what is my symbol that I have there? The symbol that you have is going to be a less than statement. So since it's a less than statement, that means it is an and statement. And what do we know about and? And means it is tracked. That x is the one that's in the middle. Okay? So the very first thing we're going to do is we're going to isolate our absolute value. So if I'm isolating my absolute value, I need to get rid of the number 3 attached to this. When I do that, I'm going to get y minus 9, the absolute value of that is less than 9. So I've done that. The next step is to check to see if it is possible. Well, absolute value is always positive, and that is going to be less than a positive outcome. Are there numbers in the world that are less than other positive numbers? The answer to that is yes. So therefore, this is possible. So I'm going to go case 1. This is going to be y minus 9 is less than 9. And then I'm going to have case 2, which is going to be negative y minus 9 is less than 9. So I'm going to go ahead, I'm going to solve case 1. I'm going to add 9 to both sides. I'm going to get y is less than 18. Then I'm going to come over here and I'm going to distribute negative y plus 9 is less than 9. I subtract the 9. I have negative y is less than 0. And I have y is now greater than 0 because I divided by a negative, so I must flip the sign. Okay, now remember, I said that this is an and what do we know about ands? Ands are going to be overlapped. So if I go ahead and I put this on a number line, I'm going to have 18 here and I have 0 here. Well, if I'm reading that y is greater than 0, that means it's open here and I'm shading to the right. If I'm reading that y is less than 18, I'm going to be an open dot at 18 and I'm going to shade down. Now, where do these two graphs overlap? The overlapping region is the answer that we are actually looking for, and that answer is going to be 0 is less than y, which is less than 18. You must always have the less than symbols. It can be less than or it can be less than or equal to depending upon what the dot is, if it's open or if it's closed. This is the answer. Now, this is doing exactly what we did last time with the equations, doing case 1 and case 2, and it works beautifully, but I'm going to show you a trick. This is the exact same problem that we just did. And what I'm going to do is I'm going to say, hey, that is a less than. So since it's a less than, I then am going to look at this number, which is 27, and I'm going to find its opposite. The opposite of 27 is going to be negative 27, which means I'm going to have negative 27 using the same sign, which is less than, and I'm going to drop the rest of the problem down. What I have done here is I've created a compound inequality where my answer will remain the same. So now I'm going to isolate, I'm going to divide by 3, but I'm going to do that on the left, the middle, and the right. So I have negative 9 is less than the absolute value of y minus 9, which is less than positive 9. Well, I don't need the absolute value anymore, so I'm going to drop them, and I have the negative 9 is less than y minus 9. And if I add 9 to both sides, I get 0 is less than y, which is less than 18. And that is my final answer, which is exactly what I got here, with a lot less work. You can only do that whenever it is an and inequality. Only possible with a less than symbol, meaning an and statement. Okay? So we're going to go ahead and go to the next thing. Okay? Very first thing I notice is I'm going to go ahead and I'm going to notice that it's a less than or equal to symbol. Then I'm going to go ahead and I'm going to say, okay, I need to isolate. So how do I isolate? I'm going to subtract 9. So I have 3 absolute value of 5x minus 1 is going to be less than or equal to 23 take away 9 is going to be a 14. Okay? Now, 3 does not go into 14. So what I'm going to do is I'm going to again notice, hey, that's an and statement. So the opposite of the number 14 is going to be negative 14. So I'm going to go ahead and make this negative 14 is less than or equal to 3 parentheses 5x minus 1 less than or equal to 14. Now I've made my compound inequality. I'm going to distribute. So I have negative 14 is less than or equal to a 15. X minus 3 is less than or equal to 14. And I'm going to add 3 to the left, the middle, and the right. So I have negative 11 is less than or equal to a 15x, which is less than or equal to 17. Still solving for x, so I'm going to divide the left, the middle, and the right by 15 to give me negative 11 15ths is less than or equal to x, which is less than or equal to 17 over 15. This is your final answer, which means if I go ahead and put negative 11 15ths here, 17 over 15 there, they are both closed dotted. So you could use a bracket or a closed dot, and then shade in the middle. That is my answer. So that is how you're going to do an and statement. Now what happens whenever I have an or statement? An or statement is defined whenever you have a greater than symbol. Now folks, there's not a shortcut to this. You just have to do case 1 and case 2 like we did before. So I'm going to isolate. I'm going to add 3. So I have the absolute value of x plus 5 over 3 is greater than 9. So immediately, I'm going to ask myself, is this possible? So this positive number is greater than a positive number. Are there numbers out there that one positive number is greater than the other positive number? The answer to that is yes, there are. So I'm going to go to case 1. Case 1 is going to be x plus 5 over 3 is greater than 9. And then case 2 is going to be a negative in front of the x plus the 5 over the 3 is greater than 9. So if I solve this first thing, I'm going to simply multiply by 3. So I have x plus 5 is greater than 27. Subtract the 5, and I get x is greater than a 22. Now, I'm going to go ahead and I'm going to take this negative and I'm going to move it down to the bottom. Why? Because that's totally legal. So I'm going to have an x plus 5 over negative 3 is greater than 9. Now I'm going to multiply both sides by negative 3. When you multiply by a negative, your inequality sign flips to give you negative 27. Subtract the 5. I have x is less than negative 32. Now remember, we know what an or statement is supposed to look like. And an or statement is supposed to have, put the smaller number to the left, which is negative 32, the larger number, which is 22, on the right. If I graph the first one, which right here, which is going to be x is less than negative 32, it is open and I shade down. If I graph x is greater than 22, it is open and I shade up. An or statement is 100% supposed to go in opposite directions. So my final answer is we read this from left to right, we place the word or in the middle, and then this is done. Okay? Again, here we go. This is going to be an and. I'm going to first isolate. So I'm going to subtract 2. So I have 1/4. Absolute value of x minus 3 is less than negative 2. Multiply by 4. Absolute value of x minus 3 is less than negative 8. And now I'm going to check to see if it's possible. This positive is less than a negative. When is a positive number less than a negative number? If you said never, you are right. So that is false. So therefore, the answer to this is no solution. It's not possible. Okay? Let's keep going. Here we go. Same thing. I'm going to isolate this. So if I isolate this, that means I'm going to divide both sides by negative 2. So I have the absolute value of x plus 4 now is greater than negative 11. When is a positive number greater than a negative number? Is it sometimes true? Is it always true, or is it never true? A positive is always greater than a negative. So since this is always a true statement, it does not matter what x is. X is always going to make this a true statement. So therefore, all real numbers. Okay? Tonight's homework is 1-6, worksheet 2, absolute value inequalities.